In episode 47, titled Validate Calculations and Code, Review, Peer Checks, Monitoring Alerts, the main theme is that validation is how a reporting system stays trustworthy when it scales beyond one person and one spreadsheet.
A quiet error in a calculation can travel far because it gets copied into dashboards, exported into presentations, and repeated in meetings as if it were a fact, long after the original context is forgotten.
The most dangerous errors are not the ones that crash, but the ones that look plausible because they blend into routine work and influence decisions without raising alarms. When validation is treated as part of normal practice, the team stops depending on luck and starts depending on repeatable checks that keep mistakes small and visible. A useful starting point is to restate the intended calculation in plain words before looking at any formula, query, or code. This step sounds simple, but it forces agreement on what the number is supposed to represent, which is where many misunderstandings begin. A metric name like conversion rate or incident rate can hide multiple interpretations, such as whether it counts unique users, sessions, or events, and whether the denominator includes all opportunities or only qualified ones. When the calculation is restated as a sentence that a non-technical stakeholder would recognize, it becomes easier to see whether the final output matches that meaning, rather than merely matching a familiar pattern of math. After the calculation is described clearly, attention shifts to inputs and definitions, because clean logic can still produce wrong results if the ingredients are wrong. Inputs include which table or feed is used, what time window applies, and what filters or exclusions are assumed, such as test records, internal traffic, or duplicate events. Definitions also include subtle choices, like whether revenue means booked, billed, or collected, or whether an active user is active in the last day, week, or month. When inputs and definitions are checked early, many errors are prevented before time is spent debating code details that were never the true root cause. Small, hand-checkable sample numbers are one of the most reliable validation tools because they make logic visible without relying on faith in a system. The idea is to choose a tiny dataset where the correct answer can be computed by inspection, such as 5 transactions across 2 categories, or 3 days of events with one obvious outlier. When the code or formula is applied to that sample, the result can be compared to the expected outcome step by step, which exposes where assumptions diverge. This kind of test also reveals whether the calculation behaves sensibly at edges, such as zero denominators, missing values, or categories with only one record. Once the calculation works on small samples, it should be compared to trusted totals and independent sources, because local correctness does not guarantee global correctness. Trusted totals might be a finance close figure, a system of record count, or a previously validated monthly number that the organization already accepts. Independent sources can include a second dataset that should reconcile, or a separate pipeline that measures the same concept differently, creating a useful cross-check. When totals do not match, the goal is not to force agreement by tweaking until it looks right, but to explain the gap in plain terms, such as scope, timing, deduplication rules, or definition differences that can be documented.
Peer review is a practical way to catch logic gaps and hidden assumptions, especially when the author has become too close to the work.
A reviewer often notices what the author no longer sees, such as a filter that excludes a category unintentionally, a join that can multiply rows, or a definition that is not consistent across reports. The value of peer review is not only to find mistakes, but to make the reasoning legible, because a calculation that cannot be explained clearly is hard to trust later. Over time, regular peer checks build shared understanding of metric definitions, which reduces the risk that a team quietly drifts into multiple conflicting versions of the same official number.
Automated checks are the next layer because manual validation is strong but does not scale well when data refreshes daily and dashboards serve many audiences. An automated check can flag sudden swings, missing partitions, or impossible values, such as negative counts where they should never appear. These checks act like guardrails, not like foolproofs, because their job is to surface surprises early when fixing them is cheap. When a key performance indicator, KPI, is monitored with simple automated sanity checks, the organization learns about anomalies from its own monitoring rather than from a confused stakeholder who notices the number changed in a meeting. Certain calculation issues show up repeatedly, and 3 of the most common are rounding, typecasting, and null handling. Rounding can change totals when values are rounded early and then aggregated, producing drift that is hard to notice until it becomes large. Typecasting errors occur when numbers are treated as text, dates are parsed inconsistently, or integer division truncates values, creating rates that quietly collapse to 0. Null handling is especially risky because missing values can be interpreted as zeros, excluded entirely, or treated as unknown categories, and each choice changes results in a different way that may or may not match the intended meaning. A concrete margin calculation scenario makes step-by-step validation feel real because margin looks simple but hides many choices. Imagine a report that shows gross margin as revenue minus cost divided by revenue, and the team expects it to match finance for the month. The first validation step is to confirm what revenue and cost mean in this context, such as whether discounts are included, whether returns are netted, and whether cost includes shipping or only direct production. The next step is to test a tiny sample with 1 or 2 items where the arithmetic is obvious, then expand to a slightly larger set and verify that aggregation behaves as expected, especially when returns or adjustments introduce negative lines. Code change tracking matters because many reporting errors begin at a specific moment, and knowing when an error started narrows the search dramatically. When changes are tracked, the team can connect a metric shift to a specific edit, such as a new join, a revised filter, or a change in how dates are interpreted. This is also how accountability stays healthy, because the goal is not to blame an individual, but to make change visible and reversible when needed. In environments where data pipelines and dashboards evolve continuously, change tracking becomes part of operational maturity because it turns "we think it changed last week" into a precise timeline that supports rapid diagnosis. Separating data issues from code issues is another professional habit that prevents wasted effort and false confidence. A controlled input test is helpful here because it holds the data steady while the code is examined, or holds the code steady while the data is swapped, so the source of the error becomes clearer. If a calculation behaves correctly on a controlled data set but fails on production, the issue often lies in data quality, schema drift, or unexpected category patterns. If it fails even on controlled inputs, the logic itself is suspect, and the fix should focus on the formula, join strategy, or filter conditions rather than chasing upstream data changes. Monitoring alerts for anomalies work best when they use thresholds and simple trend checks that match the natural variability of the metric. A hard threshold can catch impossible states, such as a count dropping to 0 when it should never be 0, while a trend check can catch sudden changes that are statistically unlikely given recent history. The intent is not to alert on every fluctuation, because alert fatigue is its own failure mode, but to alert on changes that are meaningful enough to require explanation. When monitoring is tuned to decision relevance, it becomes a quiet safety net that keeps calculation integrity from depending on someone noticing a problem by accident. A repeatable validation routine
ties these ideas together into something that can be applied consistently across reports and teams. The routine begins with a plain language restatement of the calculation, then confirms inputs, scope, and definitions, because that is where ambiguity hides. Next comes a small sample test that can be checked by hand, followed by reconciliation to trusted totals and a peer review pass to catch blind spots. After release, automated checks and anomaly alerts keep watch, and change tracking preserves the history needed to trace issues when they appear, so validation is not a one-time event, but an ongoing discipline. The close of this work is best framed as a small, concrete commitment, because validation habits improve through repetition rather than through intention. One effective practice is to choose a single calculation that matters to real decisions, such as a margin rate, an incident rate, or a customer impact count, and walk it through the full routine from definition to monitoring. The value comes from noticing where confusion could have entered, such as mismatched time windows, null treatment, or a join assumption that is not always true in production data. When one calculation is validated end-to-end and its checks are made durable, the organization gains a stable reference point, and that stability tends to spread to the next metric naturally. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.